So for sure we're increasing in difficulty. So let's move on to the next example. We're going to be finding angles given their trigonometric ratios. We're going to determine all angles that satisfy the following. Use our diagrams for explanation. So sine theta is equal to 0.272 in the domain from 0 to 360. We're going to round to 3 decimal places. Surely we've seen this question before. First step is I'm going to draw the unit circle. I ask myself, where is the sine ratio positive? And the sine ratio is positive in quadrant 1 and 2, so that's where my solutions lie. So I start off, sine theta is equal to 0.272. I apply the inverse sine operation to both sides. And very quickly, I end up seeing that this is 15.783 degrees. Now, this implied that my calculator was in degree mode because my restrictions were in degrees. So that's really my quadrant 1 solution, which is, I'm just going to write a quick 15 there, if I can. My quadrant 3 solution, or 2 solution, well, my quadrant 2 solution would be 180 minus 15.783 degrees. And what I see is that this is going to be equal to 164 now I'm going to round it to 3 decimal places, 217 degrees. And it's really important that when you're calculating your angle 2 number, that the input here is not rounded to 3 decimal places, but is really the longest approximation that you can. And that is the best use, or best stored in your calculator. And thankfully, it's also the least amount of work as well. So try to use your calculator for calculating this angle and inputting it into your calculator. Anyways, I get my solutions to be 15.783 degrees and 160.217 degrees. Moving on. I want to solve for theta. So cosine theta is equal to 0.77 in the domain from 0 to 2 pi. Again, we have solved questions like this before. So I make my unit circle. I ask myself, where's the cosine ratio positive? The cosine ratio is positive in quadrants 1 and 4. So now my calculator has to be in radian mode, because if it's not, we're going to run into problems. Mode, radian, we're good. Now I can start. So I'm going to solve where cosine theta is equal to 0.77. So if I apply the inverse cos operation to both sides, the answer that comes out should be not very nice. And what I get, the answer comes out is 0.6919 I mean, there goes more decimal places. We're going to round this to 3 decimal places, as it says. Well, does that make sense? Yeah, that makes sense, because as I said earlier, remember that the approximate value of pi over 2 is 1.57. So really, this is my quadrant 1 solution. right? Because it's between 0 and 1.57. So if I'm looking for my quadrant 4 solution now, how do I find it? Well, I have to start, easiest way is to go 2 pi minus the distance away from the x-axis, which was that 0.6919, etc. And when I do that, so my calculator, 2 pi minus my previous output, what I get is my quadrant 4 solution is going to be 5.591. So that is rounded to 3 decimal places. And I think I'm going to start rounding to 3 decimal places now. So with radians, it can be a little bit trickier. You definitely can have a rounding error due to the nature of pi. So there's my solutions. All right, next question. We are going to figure out the tan theta what angle has a tan ratio of 1/3 in the domain from negative 180 to positive 180. And we're going to state our solution in exact values. There we are. I asked myself, where is the tan ratio 1/√3? Well, I just simply remember that as these angles right here, right? Tan is 1/√3, is in the, well, I have to check. It's in degrees. So we would say that this is in the 30-degree family, correct? It's 30 degrees away from the x-axis. So for sure, 30 degrees is in this interval. And it might make more sense if I write this in interval notation. There. So we know that 30 degrees is in this, is a solution here. Another way to interpret this is within one revolution that starts at negative 180, and as we go all the way around to positive 180, what we notice is that there are 2 solutions, right? There is the quadrant 3 solution and the quadrant 1 solution. I already have the quadrant 1 solution. What is the quadrant 3 solution? Well, the quadrant 3 solution is the tricky one. And if we start at negative 180 degrees, and we go 30 degrees in the positive direction, pardon me. So, in other words, I start at negative 180 and I go 30 degrees in the positive direction. This angle is going to be negative 150. So my solutions are 30 degrees, comma, negative 150. Perhaps you don't like that. Perhaps you're like Mr. Moore and that didn't make sense. All right, so I believe 30 degrees is should be common sense. It's that negative 150 that could be problematic. Allow me to rework this a little bit. A lot of people might say, look at it like this. Well, I know that this angle right here is 30 degrees away. So if I go in the negative direction, how far do I need to travel? Well, you would need to travel 150 degrees in the negative direction in order to get to a place that you're 30 degrees away from the x-axis. So again, that's another reason why you can pick negative 150. A lot of people also don't like that. Now, you're going to have to use a lot of scruples about you in order not to mess this up. It is tricky. So here, I'm going to solve from negative 360 to 360. Negative 0 to 360. And what I can see is that this actually occurs to 210 degrees. The problem with 210 degrees is that it's outside that interval. However, I could easily find the angle that is coterminal with 210 and see if it falls in the interval negative 180 to 180. So the angle that is coterminal is going to be 210 minus a multiple of 360, and that would be 360, and that also yields negative 150 degrees. So just a quick statement, by the way, I know math teachers are probably yelling at the screen, you can't write it like this, you should write it as in ascending order. Must it be that way? If you want to be taken seriously in math, it should be written like that. On a test and all practicality, I will work through making sure that you have the proper